Hi, my name is Malini.
Hi, I'm Kaylee.
I am Joseph.
And we're humic acid removal.
So we're going to go over a quick overview of what is humic acid. Essentially, after things reach their natural expiration date and die, they start releasing a series of components that will eventually form humic acid, which can be found in bodies of water and ground. Why is it dangerous and not beneficial? Unlike in the field of agricultural, humic acid has the capability of forming compounds with heavy metals to form biometallic toxic compounds that could potentially kill someone. And they also decrease oxygen levels in bodies of water, henceforth affecting fishing and production of oxygen from phytoplankton in the seas and lakes. Next slide. So what the last humic acid group did in the previous year, a second. Okay, so last year the goal was to determine what was the optimal coagulant dosage for two humic acid concentrations, 5 milligrams per liter and 10 milligrams per liter. After the experiments were done with the different concentrations of coagulant, the team discovered that the optimal coagulant dosage for 5 milligrams per liter was 1.6 milligrams per liter, and in the case of 10 milligrams per liter, it was 1.3 milligrams per liter. And they also tried to come up with a mathematical model to predict what was the optimal coagulant dosage with a known concentration of humic acid. Next slide. As for the team last semester, the focus was to increase the concentration of humic acid and test different coagulant dosages for each. The team discovered that at a higher coagulant dosage, around 2 to 3 milligrams per liter, there was very little change in absorbance recorded, which indicated that there's a limit to how much coagulant can be put before it becomes ineffective. They were also experimenting with decreasing the amount of kaolin clay present and what effects it could have. Additionally, in the 10 milligram per liter category, they discovered that there was a strong negative association between coagulant dosage and humic acid, which we believe to be wrong. We believe there is a strong positive association. Next slide. Kaylee.
And also in the past, there were just some general challenges. As Joseph was kind of explaining, there was issues with achieving steady state and just the time that the experiments were running. In addition to getting our Percoda code and method to communicate with 4 pumps instead of 3. However, that was kind of worked out at the end of the spring 2020 semester. And then generally running out of humic acid effluent and removing the humic acid without kaolin clay, because a lot of times in the water, the clay is what creates the flock, and therefore without that clay, it's very hard for the humic acid to coagulate and be removed. So these were just some challenges that past teams have had, and we were hoping to address when we got into lab this semester. However, we were unable to get into lab, which is why we focused more on like the computation and methods side. Which leads me into our Python code. So we use this Python code that was written by past sub teams to calculate the flow rates for 15 milligrams per liter of humic acid, 20 milligrams per liter, and 25 milligrams per liter of humic acid that was being pumped into the water. And this was then related to how much water needed to be pumped in and how much coagulant as well. And so this Python code we use to create a experimental procedure and plan for different tests that a team could do once they did get into lab. On the next slide is an image of what we came up with for our experimental procedure. So we looked at these 3 different dosages of humic acid and varied the coagulant dosage from 0.4 milligrams per liter to 1.8 milligrams per liter to try to get a good range where we could find the optimal coagulant dosage for each concentration and hopefully find a better linear relationship than past subteams have found. It's kind of counterintuitive that there was a negative linear relationship. We would kind of think that as humic acid concentration increased, coagulant dosage should also be increased. So we hope that with these additional tests, a team in the future would be able to get a better understanding of the relationship between coagulant and humic acid. And additionally, we also worked on our Procoda method. The Procoda method was largely created by past subteams as well. However, we were able to download the software and open it up and really just make sure that all of our data requirements were met for each of the set points. Shown on the screen, there's an image of all of the set points that are used in our method, as well as an image of just like the Procoda set points on Procoda itself, and also the general like running interface. We kind of went through and made sure that everything checked out and was accurate, and hope that the future subteams would be able to use this like improved Procoda method to further the experimentation and just have a smooth transition into lab.
So for this semester, humic acid has accomplished a variety of tasks. First, at the start semester, the humic acid subteam analyzed reports, Procoda code, and previous problems that previous teams had faced. Additionally, we had the opportunity to meet with our RIDE mentor, Tigran. With him, we were able to ask questions about the current problems that people are having with humic acid and how we could target our research to solve those issues. With respect to starting research in person, with the assistance of Kevin Sarmiento, we were able to see the lab space in Hollister and know that the very first step would be to remodel the lab experimental setup and from previous years and determine what we would need in terms of materials and to accomplish that. However, as we were unable to go into lab this semester, we met with Monroe on redefining what we should focus on and how to work remotely. He noted that we should focus on first varying the concentrations of humic acid removal and seeing how it affects coagulant dosage. With that said, he said we should also retest previous semester's experience to determine a better linear relationship, as it should be an increasing one, but not a decreasing one. Moving forward on this goal, using the Python code, we were able to determine a set of experimental trials that Kaylee mentioned that we could test at a future date. Through Kaylee's download of Procoda, we were able to view the method file and explain each set point and ensure that all the data matches were there. Finally, we created a brief general procedure and a list of materials that future humic acid subteam removals could use later for future experiments. In general, these are the future tasks summarized for the humic acid subteam. First, we should focus on rebuilding the experimental setup and fix problems from previous semesters. What we would imagine is that once they build the experimental setup, they're less likely to have the problems as they're able to build it from scratch and fix it as they build the new setup. The second, after they retest varying concentrations of coagulant dosage with varying concentrations of humic acid and varying concentrations of humic acid that were tested at previous semesters to determine a better linear relationship, they should also try changing the pH and temperature. And finally, automating Procoda is a better research mechanism that we were trying to investigate this semester, and would allow for that to continue in future subteams so they could actually allow more trials to be run without them being present. So that's our presentation, and here are some of our appendix slides with the experimental setup that should be rebuilt for next semester. And that's our presentation. Please email us if you have any questions. Thank you.